Hello students, let us start with the next lecture. Today we'll start with the hydrolysis of salt. Hydrolysis of salts. Okay. Now there are different types of salts. Salt of strong acid. I'll be writing in short. Strong salt of strong acid and strong base. Second type you can write here. Salt of strong acid and weak base. Thirdly, you can write salt of weak acid and strong base. And the fourth type, salts of weak acid and weak base. These are the different types of salts you can see. Now, before coming to these different types of salt, as we are supposed to discuss hydrolysis of salts here, we need to understand what is hydrolysis actually. So the hydrolysis of salt, this hydrolysis of salt is defined as the reaction in which, this is the short form for which, in which cations or anions or both the ions of a salt, of course of the salt, react with ions of water. So this whole thing is related to the ions only. Ions of water to produce acidity, means acidic solution, or alkalinity, or even, or sometimes neutrality also. Means when you dissolve the salt, a particular type of salt in water, you might get acidic solution, you might get alkaline solution, or you might get neutral solution also. So we'll study one by one. We'll start with first salt of strong acid and strong base. So salt of strong acid and strong base. For example, if you take sodium chloride, so it is a salt of strong acid, that is hydrochloric acid, and strong base, that is NaOH. Isn't it? Now the ions, sodium ions and chloride ions, they have no tendency to react with water because the possible products NaOH and HCl of such reactions are strong electrolytes and they dissolve completely in aqueous solution. Means this NaCl first will ionize the salt. NaCl, it will dissociate as Na plus and Cl minus ions. Now the ions which are formed, they do not have the tendency to react with water. Because if they react with water, what is the possible product? Means Na plus plus H2O, will form NaOH and here it will form HCl here. So HCl and NaOH both are the strong electrolytes. Means even if they are formed, they will again dissociate completely in the aqueous solution. And in this way, the ultimate product will be NaCl itself. Isn't it? So the salt of this strong acid and strong base, salt of strong acid and strong base, they do not undergo hydrolysis. Remember this, huh? Salt of strong acid and strong base, they do not undergo hydrolysis because even if they undergo hydrolysis, the ultimate product would be NaCl itself. Means the sodium ions and chloride ions, they will react with water ultimately to form NaCl, NaOH and HCl. And NaOH and HCl both are strong electrolytes. Again, they will combine together to form NaCl itself. Okay. Now, this is a simple reaction you can write HCl plus NaOH in aqueous medium plus water. It will form H3O plus protonium ion plus Cl minus, that is chloride ion, plus sodium ions and OH minus ion. Okay, so neither cation, this sodium ion, nor anion, this chloride ion, reacts with water, or you can say in other words, there is no hydrolysis. Means the concentration of this protonium ion which are formed in this above reaction will be equal to the concentration of OH minus ions which are formed. So the pH of this solution will be neutral. Okay, so this is important for you. Salt of strong acid and strong base, they do not undergo hydrolysis, and since there is no hydrolysis, when you dissolve sodium chloride in water, the pH of this resulting solution will be neutral. Okay, so as I told in definition itself, hydrolysis is the reaction in which cations or anions or both ions, they should react with water to produce acidity, alkalinity or neutrality. But in case there is, even if they are forming reacting Na plus and Cl minus, they might react with H2O, but again they will form NaOH and HCl, and NaOH and HCl both are strong electrolytes. Again they would be converted into NaCl itself. So there is no hydrolysis occurring in this particular type of salt. Now the second type of salt, that is the salt of salts of strong acid and weak base. I'll be writing this in short, strong acid and weak base. For example, if you take copper sulfate, for example, copper sulfate, it is the salt of strong acid here. Strong acid here, it is H2SO4, and weak base, here it is copper hydroxide. Two OH groups will be attached to this since the oxidation number of copper it is +2. Now this copper sulfate, it dissociates in aqueous solution as Cu2 plus and SO4 2 minus. Okay. First we'll have to ionize this or dissociate rather, and then we'll try to react it with the water molecule. Now since the SO4 ions, sulfate ions, these sulfate ions here, they have no tendency to react with water because the possible product will be H2SO4. Means even if this sulfate ion, they would react with water molecule, the ultimate product or the end product will be possible product is quite obvious, that is H2SO4. And H2SO4, since it is a strong electrolyte, so again it will dissociate as H plus and HSO4 minus, remember. So sulfate ions will be released again. So this reaction of Cu2 plus ion with OH minus ions form unionized CuOH, that is copper hydroxide is formed. Means this copper ions from this reaction, you can write further Cu2 plus in aqueous media, react with water molecule. I'll put here double arrow. It suggests that the reaction is occurring weakly. Means there is a weak ionization or weak dissociation here. So CuOH twice copper hydroxide is formed plus protonium ion is formed here. Now we want, this reaction is not a balanced one. So as you all know how to balance the reaction, I will be directly writing the balanced reaction here. Here. So this now the reaction is balanced here. Now due to the presence of excess of this H3O plus protonium ions here, copper sulfate solution, it will become acidic in nature. So whether the salt solution will be acidic, basic or neutral in nature, that is decided by the further reaction when actually it undergoes hydrolysis. Remember. So these copper ions, they undergoes hydrolysis to form copper hydroxide, which is a weak base, and protonium ion is formed. So this formation of excess of protonium ions, it decides the nature of the solution. So this copper sulfate solution is acidic in nature. Copper sulfate is acidic in nature. You can test it with the litmus paper. Blue litmus will turn to the red. Now the formation of this sparingly soluble means this copper hydroxide which is forming in this reaction, it is sparingly soluble, means it is not readily soluble. It dissolves to a small extent in water by hydrolysis. This makes the solution turbid. Means whenever copper sulfate solution in copper sulfate solid or the crystal of this copper sulfate, it is dissolved in water, it forms a little bit turbidity. So this turbidity is due to the formation of copper hydroxide. So copper hydroxide forms a turbidity, means to this solution if you add little amount of H2SO4, means if you are preparing 10 liters of copper sulfate and if you are adding concentrated H2SO4, one test tube means near about 10 to 20 ml, rather 20 ml of copper sulfate is added, it will give you the clear solution. So H2SO4 is added to copper sulfate solution to get the clear solution of copper sulfate, to get the clear solution of CuSO4. And remember, this turbidity is due to the formation of copper hydroxide here. So the main focus of ours is just to find out what is the pH of the solution, what is the nature of the solution, whether it's acidic, basic, or neutral. So due to the presence of excess of protonium ion, copper sulfate is acidic in nature, though there is a formation of weak base here, but it does not affect the pH of the solution. This is the dominant one here. So if we look at this, salt of strong acid and strong means if the salt is formed by the combination of strong acid and weak base, so this strong acid will play a major role in deciding the nature of the solution. So the copper sulfate is acidic in nature. Now the third type of salt will be studying. Let us go to the next slide. Third type you can write, that is the salts of weak acid and strong base. The third combination. Now, for example, this type of salt you can write. For example, for this particular one, you can write. For example, here example is CH3COONA. Okay, so it's something is happening. I'll just make it clear. So, for example, CH3COONA. Okay. Now this salt of CH3CONA, it is formed by weak acid like CH3COH, and the strong base here it is NaOH. Now this CH3CONA, it dissociates as CH3COO acetate ion in aqueous medium, of course, and Na plus ion. Okay, this is dissolved in water. Now water also dissociates as slightly. I told this autoionization in case of autoionization of water. I explained this also. So it dissociates as H3O plus and OH minus ion. So these are the two things appearing here. Now the solution of CH3COO, it contains Na plus salt, acetate, Na plus ions, so not salt, Na plus ions, H3O plus, CH3COO, that is acetate ion, and hydroxide ion. Now the sodium ions of the salt, they have no tendency to react with OH minus ions of water. Since the possible product of this, when these two combine together, the possible product is NaOH, and it is a strong electrolyte. So if the strong electrolyte is formed, that will again dissociate as Na plus and OH minus ion. Okay, but now this acetate ion, CH3COO minus ions of this salt, they will react with H3O ions or protonium ions from water, and it will produce unionized CH3COOH. So CH3COO minus aqueous, it hydrolyzes as like this, CH3COOH plus OH minus ion. Okay. Now the equilibrium reaction for this CH3CONA. Now we have just hydrolyzed this acetate ion. Na plus and OH minus ion, they will not undergo hydrolysis. Remember, because even if they combine together, they will form a strong electrolyte. Again, it will dissociate as Na plus and OH minus. Okay. Now this, we are just concentrating on this acetate ion and protonium ion. So when you react it with H2 means nothing but a protonium ion. So CH3COH is formed and OH minus ions are also produced in this above reaction. Now the equilibrium reaction for this sodium acetate, because we are talking about salt. So we need to consider this salt also. This undergoes hydrolysis, again react with water molecule, and the reaction would be CH3COOH plus Na plus and OH minus. Now the excess of OH minus ions are produced. So you can see here in both the cases, OH minus ions are produced, and due to the production of excess of OH minus ions in the reaction, the solution will become basic in nature. So the salt solution of this, I'll write somewhere here, the solution of CH3CONA, that is sodium acetate, is basic in nature due to the presence or formation of excess of OH minus ion. You can see here. Now you can correlate with this also. Since this is the salt of weak acid and strong base, so the strong base here it is present, which is NaOH. This presence of this strong base will decide whether the solution of this salt will be acidic, basic, or neutral. So since there is a presence of this strong base in this salt, so the salt solution will give the basic nature to the solution. Next, we'll be talking about the four type of salt in detail in the next lecture, and that is about the salt of weak acid and weak base. So this thing we'll be talking in the next lecture. Thank you.